This is Unit 2, Lesson 10, Comparing Exponential Functions, and the objective is that students will be able to compare exponential functions. So, this is very similar to our last lesson that we did, where we are comparing linear functions when they were presented in context, equations, tables, and graphs. So, it's going to be the same process that we're going through. First, let's review a few terms that have to deal with exponential functions. An exponential function is a function that is in the form of f of x equals a times b to the power of x. So the big thing about an exponential function is that the input, or the x, is the exponent. An exponential function also has a starting point, which is a, and then a rate, which is b. Another term that we can use for rate is growth factor. The growth factor is the multiple by which a quantity increases or decreases over time. So if the growth factor was 2, that means that something would be doubling, so you would have a 2 in place of b. If the growth factor was half, so it's cutting in half every time, we would have 1/2, meaning that it drops by half every time. A 3 would represent something that's tripling, or a growth factor of 3. Rate of change is slope over a specific interval. And it has to be over a specific interval because on an exponential function, we look something like this. So the rate of change in this section would be greater than the rate of change in this section because it is steeper. So you have to say what interval it is because it's not a constant rate of change across the whole function. To find that, we do m equals y2 minus y1 divided by x2 minus x1. So you need 2 points. And finally, we have y-intercept. We know that the y-intercept is the place where the line intersects the y-axis, and that is always represented with an x value of 0 and then whatever y value we have where it passes through. So now let's move on and look at some different functions that are presented in different ways and compare them to one another. First, I'm going to look at a problem presented in context, or a word problem, and we're going to discuss how you find the rate of change. First, you need to determine the interval that's going to be used, and that's going to be given to you in the problem, in the question. Next, you need to create a table using the x values that you were given for the interval. So you're given 2 x values, and then you have to find the 2 y values to complete that table. After I have my table, I need to select 2 points. If you do your table with 2 points, you'll just use those 2. If you do more than 2 points, you want to make sure you use the 2 points that include your interval. And once you have those 2 points, you can use the slope formula, which is our 4th step. So that's how you find rate of change, and really that's how you're going to find the rate of change for any type of problem. The y-intercept is what's going to be a little different. When you are solving a problem from context, to find the y-intercept, you just need to look for something in the problem that talks about the initial value or the starting point, something along those lines. And that's the same way we find the y-intercept in context when we're talking about a linear function. Now let's look at finding rate of change and y-intercept from a word problem. Or not from a word problem, that's what we did. We're going to look at finding it from an equation. To find the rate of change, you need to first determine the interval. After you determine the interval, you are going to substitute the x values into your equation to come out with the 2 y values. So we have step 2 and step 3, find the first and second point by substituting x1 and x2. And then finally, step 4 is use the slope formula. So these 4 steps will help us figure out the rate of change. To figure out my y-intercept, I need to substitute x with a 0 in the function f of x. And what that's going to do is give me a point that has an input of 0 and then an output of the y-intercept. Let's take these 2 different ways to present the information and compare them with a real example. Our example says a petri dish contains 8 bacteria that double every 15 minutes. Compare the properties that represent this function to the function g of x equals 8 times 2 to the power of x divided by 10. So first, let's start out with the petri dish. This is a word problem. So I am going to determine the interval observed, which I forgot to write down before, and that interval is 1090. Well, if I want to plug 10 and 90 in to create a table, I need to figure out what equation this word problem represents. So I see that it starts with 8 bacteria. So I'm going to have y equals 8 times. For my growth factor, I have double. So that's going to be a 2. And then every 15 minutes. If it was every minute, I would just have an exponent of x, but since it's every 15 minutes, I need to do x divided by 15. So on my table, I'm going to have x values of 10 and 90. And to calculate what my y values are going to be, I will plug 10 in place of x. And then I will plug 90 in place of x. So when I use my calculator, I end up with the numbers 12.73 and 512. So step 1 was to determine the interval. Step 2, create a table. Step 3, select 2 points. My first point is 10, 12.73. My second point is 90, 512. Now finally, I'm just going to label these as x1, y1, x2, y2, and then use my slope formula. So we have m equals 512 minus 12.73 divided by 90 minus 12. And when I use my calculator, I find out that that is 499.27 divided by 80, which gives me a rate of change of 6.24. Now let's calculate rate of change for the function g of x. I have to do g of 10, and then I have to do g of 90. G of 10 equals 16. G of 90 means I'm replacing the x with a 90. And G of 90 is going to end up equaling 4,096. Well, already I see that there's a big difference between the y value when x was 512 and the y value over here. sorry, the y value when x was 90 and the y value when x was 90 for this one. So the 2 points that I have are 10, 16, and 90, 4,096. Next thing I need to do is take x1, y1, x2, y2, and plug those all into our slope formula. And that gives me 4,080 divided by 80. Which is 51. So I have one rate of change that's 51, another rate of change that is 6.24. So my slopes are very different. One is increasing at a much greater rate than the other. Now let's take a look at our y-intercepts. We could find our y-intercept by substituting 0 back in place, or we could also look at the starting point. So it tells us here that we begin with 8 bacteria, so we replaced A with an 8. Over here we also have A replaced with an 8. So these two functions are starting at the same point, but the second function has a much greater growth, or not growth factor, but a greater rate at which it's doubling because it doubles every 10 minutes rather than every 15 minutes. Alright, we're going to go over how to find the rate of change on a table and graph, and then we will do an example of that in class. To calculate rate of change for a table, first you're going to determine the interval. Really, that's always going to be your first step when you're talking about rate of change. After you determine the interval, you kind of get to skip a step and go straight to identifying 2 points. Obviously, you're going to use the two x values that were given to you in the interval, and then use the y values that are associated with that. So if I'm given x1, I have to use y1. If I'm given x2, I have to use y2. After you've picked all of those out, you can go ahead and use the slope formula, and then you will have your rate of change. Y-intercept is also a pretty quick one on a table. For the y-intercept, you need to identify the coordinate that represents the y-intercept. So that means you have to find the coordinate on your table that has an x value of 0, and then whatever y value is with that is going to be your y-intercept. Finally, we have a graph. And as you can imagine, calculating the rate of change begins by first determining the interval. After you figure out what your interval is, you can just pick 2 points. So the table and the graph are very similar. We don't have to calculate anything. We just have to look at the table and figure out what x1 and y1 are. And then we have to figure out, I know x2, what's y2. And then once again, just use the slope formula. The y-intercept is probably the easiest to find on a graph. All you have to do is look at the graph and ask yourself, where does the line intersect the y-intercept, or the y-axis? And then that tells you exactly where your y-intercept is by using the coordinate 0, y. So these 4 methods that we reviewed shouldn't be new to you. They should all be old things that we've done in the past, and just a good quick refresher to you of how it is done.